Hi everyone, it's Tara. Welcome to the channel. In this video, I'm going to do another TryHackMe walkthrough and continue playing through the attacking and defending AWS learning path on TryHackMe that I have been making some video walkthroughs of just for fun. And I'm a big AWS nerd. If you watch some of the other videos, you probably know that. And really enjoying this AWS learning path that TryHackMe put together. So this video focuses on the STS Credentials Lab, which STS stands for Security Token Service. It's a service of AWS. And I actually just finished playing through the STS Lab and then came back to make this video. And this was probably my favorite activity room so far on the AWS learning path. It's all about STS, assuming roles. We learn about long-term credentials, short-term credentials. And I thought it was very realistic and relevant to some different use cases and topics that you do hear about a lot in the world of cloud security. This room is also the last room in the IAM module on the attacking and defending AWS path. So this wraps up IAM and applies some of the knowledge that we have learned about in the other IAM rooms. With that all said, this is my video walkthrough of the STS Credentials Lab, and I hope you enjoy it. So here we have the STS Credentials Lab, and the description says, learn how to assume roles and get temporary credentials. And I decided I'm finally going to give in and use the TryHackMe attack box instead of my local terminal for running AWS commands, because I realized I could have this nice split screen. It'll look a lot nicer for sharing my screen in this video. So these are the sacrifices I make. I'm going to get the attack box started to run commands in AWS. And task one is called an introduction to STS credentials. But I guess until I need this, I think I can make this smaller, right? How do I hide it? X's. All right. Task one is called Introduction to STS Credentials. Understanding how credentials are generated and can be leveraged is critical for understanding how to attack or defend a cloud account or application. In this room, we will walk through the creation of a new IAM user and an IAM access key for that user. We will then use that key to assume a different IAM role to get temporary credentials. You can refer back to the AWS API access key and how services get credentials task in the IAM credentials room to refresh if we need to. And I do have a video walkthrough of that room if you want to go back and look at those tasks. In the above diagram, the IAM group and the IAM policy that has the actual permissions and the role already exist. Okay, so in this diagram, when I try and make it bigger, it goes into this weird like dark mode, but the text color doesn't adjust. So, okay, I'll give up and stop doing that. But so it says in the above diagram, the IAM group, IAM policy, which has the permissions, the policy contains the IAM permissions, and the role already exists. So that would be the IAM group, and it has this permissions policy attached to it. That's already there, apparently. And then this role already exists in our AWS sandbox as well. We are going to create the IAM user and long-term security credentials. So that will, I imagine, be an access key we're going to create for this user. From the attack box, we will use the long-term credential to authenticate to STS, the security token service, to assume the role. And then STS, when we assume the role, is going to return session credentials. So those are the temporary credentials. And just side note, you might remember if you played through the IAM credentials room, these short-term credentials will start with ASIA, and these long-term credentials will start with KIA. So that's a quick way when we're looking at them to remember. So our user is going to use the long-term access key to authenticate to STS and then assume the role via STS. And then STS is going to return those temporary security credentials needed to authenticate to the role. All right. Or authenticate as that role, it says. If you haven't already done so, click the orange Cloud Details button at the top right of the page to generate the environment and use the credentials provided to access our AWS sandbox. All right, so I do think we maybe need to generate new infrastructure for this room because I don't see STS Lab here. So and we know we need new stuff for our AWS environment because this green button is here. So we're going to generate the environment so that it can spin up the role, the group, and the policy for me. And I'll just point out here also, so it looks like the IAM user itself does not have a policy attached to it, but it will still inherit permissions from the IAM policy that is attached to the group if it's going to be a member of the group. So these permissions will be applied. All right, and then it also says, for this room, make sure to start the attack box and prepare the AWS Cloud Shell in your AWS Sandbox account. We will create a user in the Cloud Shell then simulate the exfiltrated or on-prem usage of the credentials on the attack box. Okay, cool. So we're going to use Cloud Shell as well to actually create our user. So I already logged into the AWS sandbox for TryHackMe, and I'm just going to go to Cloud Shell. You can just search right here, Cloud Shell, which is the browser-based shell that's already all set up for the CLI for us. So here we are. Welcome to AWS Cloud Shell. And I think I'm getting this permissions error because my environment is still currently generating. So I don't have the right permissions to use this yet, but I'll refresh as soon as the environment's done. All right, so that is task one. We just hit completed, say we are ready. We know what's in store for us. And then we can move on to task two, which is the accessing the environment task. So we already just did that. This is about how we make sure our environment's working correctly. And we've seen this a few times now if you watch any of the other AWS videos, but basically you walk through these steps and use this generate environment functionality. I'm just going to hit completed. Whoop, whoop. And that brings us to task three, where we're actually going to get started doing some things in the cloud. And our cloud environment is ready. It has loaded. So our sandbox is ready with what we need. And we can move on to task three. Task three is called create the Padawan user. So I think these are Star Wars references, right? I always say that. Like, people probably think I'm joking in these videos because I always say that, but I'm really never confident that something I'm seeing is a Star Wars reference until I see the font or other confirmation. So I think Padawan is Star Wars, but that will be embarrassing if I'm wrong. And we're going to start by creating the IAM user Padawan. IAM users are the easiest way to grant access to a system outside of your cloud environment. So we're going to do this in Cloud Shell. So earlier when I was talking about starting up the attack box, I thought I was going to use the attack box to run my AWS CLI commands, but that was wrong. I think I'm going to use the attack box to exploit the IAM credentials after we've created them. So the attack box is going to be the attacker, the bad actor, and it's going to be Cloud Shell that is actually authenticated to the AWS CLI for our TryHackMe account. Okay, so we've got TryHackMe on the left. We have Cloud Shell on the right, signed into the TryHackMe AWS account. I refreshed the page now that my stuff has all generated. So I am in for Cloud, and we are going to create the Padawan user. So we are going to do that by running some AWS commands. We're going to do AWS IAM create user, and the username is going to be Padawan. And we see this output. So that means we successfully created our user. And remember, we learned about those IAM prefixes before. So we know the IAM prefix here, AIDA. We'd see that. We would know if we were to see that ID without the user ID key, we would still know that's an IAM user. All right. Now we are going to grant Padawan some permissions by adding them to the Padawans group. And the group already exists in our account. We could probably even see it right here if we want, just to really dive deep into what's going on. I'm such a dork. Whenever I search for the IAM service in AWS, I always type AWS in front of it. I don't know why I do that. It's such a habit just for IAM. I guess maybe because you find yourself referencing like GCP IAM often, or just the concept of IAM in general. Maybe that's why I always think I need to delineate AWS IAM. Anyway, what were we doing? Okay, so here are the user groups that exist in our TryHackMe account already. So we have Padawans group and the STS rooms group. And I think we're going to add Padawan to this existing group that was already created for us. And here are the permissions that are attached to that group, the assume Jedi role. So when we add Padawan to this group, Padawan is going to have these permissions as well. Okay, so let's do a copy and paste. We can do AWS IAM add user to the group, and we're going to add Padawan to Padawan's group. All right. And now that we have created the user identity, we're going to create the access keys that we're going to use on the attack box in the next task. So we're going to save the output of the create user command so that we can validate the identity in a user task. So we're going to save the output of this command. And I don't know, I'm not necessarily sure they mean save it into a variable, but we could do that. Let's just do that. So let's do AWS IAM list groups for user, tac username Padawan, and then we can save the output to, let's just do output.text. Let's just do a really descriptive name. That will be easy to remember. And then we can do cat output.txt. So this was the output, and we've got it saved here so we can reference it again. What are the first 4 letters of the group ID of Padawan's group? And remember, we don't even actually need this output to answer this question if we just remember what the IAM prefix for groups are. And I think it's AGIA. Oh, no, AGPA. Okay. So we did need to run that command in that case. But in general, the idea is this prefix is the same for every group, AGPA, for every IAM group ID. So that is task 3. And now on to task 4, where we are going to create Padawan's access key. Having created the identity and granted permissions by adding the user to the group, you have configured authorization for this user. And authorization is what you are able to do, what you're authorized to do in the domain. In this task, we configure the ability to authenticate to the AWS APIs, and the authenticate is who you are. So to access the Padawan user on the attack box, you will need to generate an access key. So this is the same as like what we've seen before, where we go to a user in IAM and we go to security credentials and we scroll down and we create an access key here. This command is doing the same thing. So let's run AWS IAM create access key user name Padawan. Sometimes I just like to type these out. I don't know. I find it relaxing. So let's do that. And now Padawan has an access key. Note this is a long-term access key with the AKIA prefix, and there's no expiration because it's not a short-term credential. So we can come over here and do a refresh. And now Padawan has an access key. So now we need to start the attack box back up to start our attack. So I'm going to minimize my Cloud Shell in my AWS, and I'm going to show the split view for the attack box. All right, very nice. I love this beautiful gradient so much. It brings me joy every time I see it. Okay, so we're going to go to the attack box and issue these 2 commands. So we're going to set the environment variables here for AWS secret access key and AWS access key ID. Using these environment variables is another way to authenticate with the CLI. And there's something called, I'm forgetting the exact name, but there's the idea of authentication precedence. So the CLI, when it's trying to authenticate you to run a command, will go through a certain order of where it tries to find credentials and figure out who you are. So I think we could even probably look it up. So let's do precedence. I don't know how you spell precedence. AWS CLI authentication. So, okay. So apparently I have looked this up before. Let's see if this is the right one. Yeah. Okay. Credential precedence. Credentials and configuration settings are located in multiple places, such as system or user environment variables, AWS configuration files. And when you run the AWS configure command, you're creating local configuration files or explicitly declared on the command line as a parameter. So this is the order of precedence. So if we were to use command line options like profile, which is what I use every time I run my TryHackMe profile, that's number 1. That will override any environment variables you have set up or any configuration files. And then environment variables is second in the precedence order. So if you have any environment variables set with your AWS credentials, that's the second thing the CLI will try to use. So I will link this. This is a good resource, the precedence. And okay, but anyway, on a tangent already, can't help myself. All right, I rearranged my tabs a little bit here. So let's go back over to Cloud Shell, and we're going to get the access key ID from the access key that we just created for Padawan. And we can do export AWS secret access. I think I got the access key ID. Let's see. Yeah, I got the ID. So we can tell that from AKIA. So we'll do that. And then we can do export AWS secret access key. And this will be the key itself. And I'm sure we're going to delete it at the end of this lab, hopefully. All right. So I keep trying to use Command V and it doesn't work on the attack box. I wonder if there's a way I can change that. I bet there is. I'll try and figure that out for you by the next walkthrough so you don't have to watch me clunkily doing that. Anyway, so we're going to use these environment variables. So we've got our environment variables set up. We hit enter. What is the character length of the secret access key? Well, oh my gosh, I certainly don't want to count it, but I bet I can copy it. So I'm going to do what I do in any situation like this, and I'm going to ask ChatGPT to do this for me. So how many characters is this? And let's see what my best friend ChatGPT tells me today. Analyzing. So this string is 40 characters. Thank you, ChatGPT. And then let's say, is every AWS access key 40 characters in length? So it says, yes, they are all 40 characters in length, but they're not fixed in length at 40 characters. All right, so that was maybe not a fruitful second question. But the first question, this is 40 characters in length. Let's see if that's right. And, come to think of it, there must be some sort of consistency that with 40 characters in length, because otherwise, how could TryHackMe have this be the right answer to the question? Because every access key is going to be different. All right. Anyway, the point is you get the access key and you figure out how long it is. All right. So that was task 4. And then for task 5, we are going to validate our status on the attack box. So the STS get caller identity command is the AWS equivalent of the Unix command, who am I? And this is a great command to have to memory. I use this quite frequently. You should use it regularly to make sure you know which account or user role you're working with. And this is how you do it. So we can do AWS STS get caller identity, if I spell it right. And this should tell us the entity, the principal we're authenticated with in AWS. All right, so awesome. So we can see we are authenticated with this user ID, and we can see the username here is Padawan, because that's always the last part of the ARN. So our caller identity is the Padawan user. It says the user ID you see here should match the one from task 2. Hold on to the account ID returned above. You will need it for the next task when our Padawan user assumes a new role with more permissions. Hold on to the account ID above. Okay, so we'll just maybe not clear our output. And we can confirm when we created our Padawan user, here was the ARN for our new user. So we can see that ARN matches this. Perfect. So we are the Padawan user. And let's see. Now we are going to assume the role of Jedi Master. This is like escalating so quickly. Now that you use long-term access keys from an IAM user, so that's what we were doing, right, with the CLI. We set those environment variables using the long-term security credential that authenticates us as the IAM user. And now that we've used those long-term access keys from an IAM user, we're going to generate short-term keys for an IAM role. In many attack scenarios, you'll be leveraging these short-term credentials, so it's important to understand the basics of this. So the next step, we're going to assume the Jedi Master role, which is that role that was already in our account when we got started with this room. We can open the IAM roles in the console, and here's the Jedi role. Let's see what it has permission to do. So it has, it doesn't have any permissions. Okay, so the Jedi role doesn't have any permissions, but let's imagine it has like some really high stakes permissions just to make this exciting for ourselves. All right, so the next step is to assume the role of Jedi Master. To do this, we need 3 things. We need permission to assume the Jedi role, and this is provided by the policy attached to the Padawan's IAM group. So this policy right here that Padawan is inheriting from this group has the permission we need to assume the Jedi role. And let's see what that looks like. So here is Padawan, but actually we want to look at the group because Padawan themselves does not have permissions. So here's the group, the Padawan's group, and here's the permission that allows us to assume the role. And the only role we're able to assume with this permission is the Jedi role. And that's done with the resource block here. Okay, so the ARN, the Amazon resource name of the role we want to assume. So we've got that. And then the role session name. This string appears in CloudTrail logs. We haven't talked a lot about CloudTrail in this learning path so far, but I think we're going to learn more about it. And help administrators distinguish who or why a specific role was assumed. So for this, we're going to use the name of someone who almost became a Jedi Master. This is going to be lore. That goes way over my head. But we're going to use this command. So we're going to kind of build the command piece by piece. So we're going to do AWS STS assume role. And then we can do tac role ARN to say the role we want to assume. And I'm just going to come over here to this Jedi role and grab the ARN. But you could also build it yourself using this logic. All you need is your account ID for the TryHackMe sandbox. And then What's next? Role ARN. And then that's the role, the Jedi role. And then lastly, we just need the role session name, and we're going to name the role session Ahsoka. Okay, perfect. So I'm guessing Ahsoka is the person who almost became a Jedi Master. Now we are going to take the output of the assume role command. So let's run the command. Let's see if we got it right. The suspense is the suspense is building so intensely. Did I not hit enter? No, I did. It's just slow. I think I did. Okay. So here's the return from that command. So here are the short-term credentials we got. And remember, we can tell right away these are short-term credentials because we have the ASIA prefix for the access key ID, and we have an expiration because they're short-term credentials. So these are the temporary security credentials STS returns. Okay, so now we are going to take the output of this command, and we're going to set the 3 AWS CLI environment variables required to use temporary credentials for the role. So we had set those environment variables for these, but now we're going to change the environment variables to use these temporary credentials. And we probably should have saved this like I'm going to do this again. And I'm going to save, I'm just going to do creds.txt. Oh my gosh. Sorry, this is really laggy for a minute here. Okay, so since I directed the output of this command to creds.txt, now I can just do cat creds.txt. Then I can have this all here nice for me. So the key, so we're going to do export AWS secret access key. And that's going to be this value right here, secret access key. I just need this to be a little longer. I suppose maybe I control that. Let's see. All right, and then we need the access key ID. Oh, how do I make it shorter? Okay, so then we need the access key ID that starts with the ASIA. And then lastly, we need the session token for the session that we created when we assumed the role with the special name and everything. And so let's just get the whole session token with the quotes and everything. And paste. Okay, so now our CLI should be authenticated with the short-term credentials returned from STS. How many minutes are your session credentials good for? Okay, so we have the expiration. Okay, so we have the expiration, and I think, oh my God, I'm so bad at this. I'm going to ask ChatGPT, how far in the future is this? Hiya. In Mountain Standard Time, when would this token expire? If this is the expiration. And let's see what it's got for me. At 16:16:47. Okay, so that would be 4:16, and I bet I created that around 3:16. Now you know it's the afternoon for me, so use that information as you will. But anyway, so what I just did there, so this is an ISO 8601 timestamp. So you could use a converter, or I just asked ChatGPT to convert it for me. And the expiration, it looks like the session was good for 60. All right, so there we go. And then how many AWS CLI environment variables did we have to set? So we set 3, the access key ID. I guess that was right here. Oh yeah, so we set 3, the access key ID, and the session token. So that's 3 environment variables. And then for task 7, we are going to validate our newly found powers. So let's see what's going on. Now that we configured the AWS CLI environment with your new credentials, verify you're acting as the Jedi role. And we can do that. We learned how to do that before, right? So we can just once again run AWS STS get caller identity. And instead of being the user, which we were before, we should now be the assumed role. So before, I think I cleared the output, but before when we ran AWS STS get caller identity, we were returned the user, right? The RN for the Jedi user. But now that we're using those short-term credentials, we're using the assumed role Ahsoka. And so if Ahsoka had different permissions, that role had different permissions associated with it, we would be able to use those permissions to run commands. So what IAM resource does the string that begins with AROA represent? So that represents an IAM role, and IAM role IDs are always going to start with AROA. So when we see that, we know it's a role. Okay. And that is the end of the STS Credentials Lab. That was a great room. I really liked that and illustrated a lot of good things about IAM credentials and was good practice for me too. If anything else, if you just remember STS get caller identity, that's really useful. So with that being said, we're getting into the fun stuff now because we're really like starting to apply the knowledge. We're doing some actual kind of like hacking stuff. And the next room up, we're going to progress to the attacking and defending AWS services module. And the first room is going to be attack and defense for AWS S3, which is storage buckets. I'm sure that will be very fun. I work with S3 quite a lot, so hopefully I'll hold up okay. Thank you so much for watching this walkthrough, and I will see you next time.